We're going to look at part of section 4.2 today. Okay, so Friday I try not to keep you the whole time, so I'll keep an eye on that, and we'll be able to finish whatever we don't get to today on Monday. So get through part of this section. This section is not bad either. If you felt like you were pretty comfortable with 4.1, then you'll be in good shape on this section too. This section we are dealing with not rates, but ratios. And again, there's a little bit of vagueness with what we'll call which one. Remember with rates, we said we had a fraction where we were comparing two quantities and they may or may not have the same units. With the ratio, we are going to have the same type of unit. Okay, so top and bottom is going to be the same type of quantity. And here in just a second, we'll see that that's a little bit debatable too. So ratios, rates, they're really almost interchangeable. Okay, the two terms. So the idea with a ratio, since we have the same units, is a lot of times we can get away without having to write the units down. And because of that, we have several different ways that we can represent ratios. Okay, so there's really three ways to write them down. You can do a ratio with just words. You can just put 2 between the numbers. So like this first one, we would say we have a ratio of 1 to 2. Okay. You can put a colon between the two quantities, and you read it the same way. You still say that's a ratio of 1 to 2. Okay. Or we can write it as a fraction. Okay, we'll put the first number on top, the second number on bottom. And there, if you know you're dealing with a ratio, you could say that's a ratio of 1 to 2 when you write it that way. Or you can say our ratio is 1/2. That's okay too. Either way there. So just pick what you like the best. If we are doing an equation, then the fraction form is usually a little easier. But any other time, you really just pick what you like. Okay. All right, so let's write some. I know this. It's kind of trivial. Okay, we just have to make sure we're writing things in the right order is really the only thing that we're concerned with here. Okay, so this one says, on a university campus, the fall enrollment shows that the new freshman class consists of 321 women and 214 men. Write the ratio of men to women. So it is very important that you look at which one they put first and which one they put second. Okay. So we want the ratio of men to women. So as a fraction, that'd be 214 men to 321 women. That works. One thing we typically like to do, instead of, if we can, instead of leaving our numbers like they are, we want to look to see if we can simplify any and see if we can reduce our ratio. It's just like simplifying a fraction. We would look to see if any number goes into the top and in the bottom. And this one's not real easy to pick out. But 107, 107 will go into the top and in the bottom. And you're forgiven if you didn't notice that. But here we could write this as 2 to 3. When we simplify. Or how else can we write it? We can write it 2 to 3. Or with a colon, 2 to 3. Any of those are fine. And then I'm gonna kind of remind you of something here. We said ratios have the same units. This one's a little weird because we're doing men to women. Okay, but the idea here is we're thinking about our units being people. Okay, so just a little bit of ambiguity in our definition on ratios and rates, but it's okay. Questions on that one? Sorry, that one's kind of tricky to reduce, but 107 is not the first thing I check for when I'm trying to simplify a fraction. That's how that thing turned out. Okay. So we've actually seen something here that we can put a name to when we simplified this ratio, and that's this idea of equivalent ratios. Okay. So the idea is that any ratio we can really write down infinitely many ways. Because if we multiply the top and bottom or divide the top and bottom by the same number, we get what we call an equivalent ratio. So there, what would we have? We had 231 to, no, what was it? My short-term memory is going on me. 214 to 321. And that was one way we could write a ratio, and then when we simplified that to 2 to 3, we get an equivalent ratio. So let's make an equivalent ratio here. There, I've got a ratio of 3 to 5. So how could we come up with some other equivalent ratio? What could we do? Normally you think about simplifying, right? You would say if there's anything you can divide into the top and the bottom, but if we're just trying to come up with any equivalent ratio, we don't have to make it smaller, we can make it bigger. So anybody got one that would be 6 to 10? Yeah, that would be great. 6 to 10, okay, that's equivalent, or you could do 60 to 100. That's one we think about a lot. 60 out of 100 would be 60%. We'll talk about those later. And we could do 600 to 1,000. Whatever. We multiply the top and bottom by anything we want to, and we get an equivalent ratio. And we could go backward. It's a little weird if we do. Like we could make our numbers smaller. We could say this is equivalent to, if we divide top and bottom by 2, we could say we have like 1.5 to 2.5. Normally we don't do that. Normally we stop when we get the smallest whole numbers that we use. But this is allowed. It's just not typical. Okay. Let's see here. Look at another one here. All right, this one says a local radio station says that out of every 10 listeners, 6 are women and 4 are men. Write the ratio of women to men listeners in lowest terms. Okay. So that means we want the smallest whole numbers we can use. Okay. So again, the main thing to focus on these is what order we're doing them in. So here we want the ratio of women to men. So it told us we had 6 women for every 4 men. Okay. And if we put that in lowest terms, what's that make our ratio? Instead of 6 to 4, it's 3 to 2. Yeah, 3 to 2. Okay. And again, you could write it with a colon instead of like a fraction if you want to, or you can write it with words. Okay. Any of those are okay. I personally like doing it like a fraction. You can do it however you want to. Okay, out of those 3. Okay. Let's look at another way these can be worded. Okay. This one got a two-parter. So it says, according to Fortune's 2011 list of the top 40 under 40, 40 people under 40 years old, the up-and-coming top 40 adults in America includes 15 women. And A says, write the ratio of the number of women on the list to the total number of adults on the list in all three notations. So again, we just have to pay really close attention to what order they're wanting us to write things and what numbers they're telling us to use. So in this one, we want the ratio of women to adults. So we've got 15 women out of 40 adults. 15 out of 40. And it doesn't tell us to put it in lowest terms, so we're okay. We could simplify. But we'll just leave that one since it doesn't make us simplify. Okay, so that's one notation. Other one we could say 15 to 40, or we could say 15 to 40. Now B is the one that we have to think a little bit harder on. Not much, but a little bit harder. B says write the ratio of women to men. Yeah, so how do we figure out how many men we have? It doesn't tell us, but it does tell us the total we have. It tells us we have 40 adults. And we know 15 of those are women. So here we're saying we got 25. And so the ratio of women to men, 15 to 25. Sometimes you have to do a little bit of subtraction. Keep an eye out for that. Okay. Question on that one? Hopefully a lot of this is really just refreshing your memory, reviewing a little bit. Might have been a while since you've seen this stuff. Mostly everyone should have seen it at some point. Okay. Yeah, it's just this one, we're not really going to calculate anything. We're just wanting to look at what's going on this one. Okay. We could do calculations, but there's a lot going on here. So once we get there, sorry. Okay. All right, so on the next slide, we got a table that shows us a study by some online health journal that's claiming, we got some dietary things here that, so the idea here, okay, we're talking about different kinds of fish and their benefits for heart disease. The idea here, I don't know how much you know about it, but there are these omega fatty acids, okay? And there's two main types, okay? So we've got one that we don't want as much of, and it's called omega-6. Okay? And then there's one that's supposed to be beneficial for your heart, okay, that we call omega-3. And what they're saying here is that if you have farm-raised tilapia, or the type of fish, and then the ratio is 11 to 1. And so is that good or bad? Well, that we have to look and see what order they're putting it in. Okay. So here the bad ones come first, omega-6, bad. Okay. You just don't want too much. Okay. The bad ones come first, and then the good ones, omega-3s, come second. So saying we have a ratio of 11 to 1 there. And what we're doing with this table on the next slide is we're comparing that to other types of fish. Okay. And what we're given like just an amount of the different types of fatty acids. Okay. And what we can do so we can make a comparison is we change each one to a ratio. And we got to put it in the same order they put theirs. So we're going to do omega 6s first, and then the omega 3s. Do that. Get these ratios. And that's okay, but these are hard to make sense of because some of the numbers are pretty big. Like I really don't have a good idea in my brain of what a ratio of 239 to 3096 means. So what we can do to help with that if we're trying to make a comparison is we can reduce these. We can divide. Let me see what they divide by here. Because we're trying to compare it to a ratio of 11 to 1. So what they're going to do on each one of these is they're going to divide by whatever the bottom number is, so we end up with a 1, kind of like we did with unit rates. But when they do that, since the numbers on the right are bigger, we're going to get decimals on the left side numbers. That's okay. Here's where we end up. It'll make more sense when you see it. Okay. So they're dividing by the bottom number, so we end up with a 1 on the right side. And then here's our farm-raised tilapia. So the point they're trying to make is apparently you don't have a good ratio of the bad fatty acids to the good fatty acids with farm-raised tilapia like you do with these other fish. That's all that's going on there. Any questions on any of that? I know I didn't make you do a calculation, but just wanted you to kind of see what was going on. Okay. I'm not sure if that's true of wild tilapia. If you're actually interested, I'm not sure, but it was the farm raised that they were looking at here. Okay, that'd be something interesting to look up. Okay. So good to know here. This one we will calculate. This one gives us a map. Anybody know what a map is anymore? I'm just kidding. I know you do, but I do like all the rest of you. If I want to know how to get somewhere, I'll get my phone out and use some type of map app. But we still have this kind of thing. Okay, we got this scale down here. So part A says if the distance on the map between point A and point B measures 3 inches, what is the actual distance between these points? And it gives us this thing down here we call a scaling factor. It says 1 inch on our map equals 5 miles in real life. Okay. So we can use that ratio. And it is a ratio even though it's inches to miles because our units are distance. And we can use that ratio to figure out A. You can probably figure that one out without having to write it down. So if 1 inch is 5 miles, how far is 3 inches? Don't overthink it. Okay, we're at it now. A. So we said 1 inch, 5 miles. Pen's got squiggly today. Okay, and we want to know how many miles 3 inches would be. Okay. So is that going to make, can you see it now? Okay. It's okay, we can do the equation, right? We cross multiply. We get x equals 3 times 5. Okay. Get 15. 15. Multiply by 3. See, I don't know if you didn't see that or if you're just real quiet today. Is everybody sleepy? Almost everybody sleepy? Is anybody like really fired up and ready to attack the day? Okay. Oh, you are? All right, good deal.
I'm trying to conserve energy for the weekend.
Saving energy up. Okay, all right.
For Dan.
All right, okay.
That's perform the show in 2
2 and 1. Okay. So you gotta do halftime, then you gotta do pregame.
Captain.
Gotcha. Busy day tomorrow for Southern. So. Okay. All right, let's look at B. We'll get through this. Let's look at B. B says if you wanted to take an 11-mile walk one day, what would that distance be on the map? Okay. Same idea, we're just using it the other way around. Okay. So for B, we're taking an 11-mile walk. Okay. And we know that one inch, well, I got to do it upside down. 5 miles is 1 inch. We want to know how many inches that'll be on the map. So the important part on setting these up, you can set them up 2 different ways. You can either make sure that the miles are on this one side and the inches are on the other side. Or you can do like I did here, which is how I normally end up setting mine up, where I've got the miles on the top and the inches on the bottom. What we can't do is we can't have miles on top there, inches on bottom there, and then inches on top here, miles on the bottom. I got to match up. So either the miles have to both be on the top or both be on the left. They both have to be in the same place. And on this one, it takes us a little bit more effort to solve. We've got 5 times x is 5x. And 11 times 1 is 11. Okay. What do we do there? Divide both sides by 5, so we get 11 divided by 5. So let's see what that is as decimal. Again, I'll write it up here so you can see it better. 2.2 inches. Almost miles. Questions on that part of that one? Okay. Let's do one more and I'll let you out of here. It's Friday, so. One more, hang in there. One more. Let's try to be a little more pepped up for this last one. Be a little more excited about it. Okay. Me too, I'm talking to myself too. I'm not always really excited about doing math either. One more. All right, this looks like a good one. It says, suppose we know the distance from Chicago, Illinois to Albany, New York is 816 miles, but on the map, the distance from Chicago to Albany is 1.4 inches. Then we're going to use that ratio to figure out how far it is from Chicago to St. Louis, Missouri. If the distance on the map between those 2 cities is 0.5 inches. So we got several things going on here. Okay, we're coming up with our own scaling factor here. So instead of us having the map with a little scaling factor down on the bottom, we got to come up with our own ratio. We can do it. We can do it. So what do we know? We know the distance from Chicago to Albany is 816 miles in real life, 1.4 inches on the map. So we can use that information to come up with our scaling ratio. And we know 816 miles over 1.4 inches. We've got that ratio. And if we want to help ourselves out, we can divide the top and bottom by 1.4. Because if we do that, it'll make the bottom come out to 1. It'll be easier to use in the next part. So if we do that, I'm going to round a little bit here. That tells us that about 582.9 miles is 1 inch on the map. That's my scaling factor. So I just divided top and bottom by 1.4. So it makes the bottom of this come out nice, right? It makes it come out to 1 inch. It's easier to use for the next step. Then what's left? If we want to figure out the distance between Chicago and St. Louis, if we know the distance on the map's 0.5 inches, so I'm going to take my scaling factor, 582.9 to 1. Maybe I had to. My brain's a little sleepy. Look at it written. So yes, you're right. Because, well, I think it turns out being multiplying. Because on the map it's 0.5 inches. We want to know how many miles. So if we set up our equation, we got something miles has got to go on the top the way I have it set up, and something inches has to go on the bottom. So the one we know is inches, 0.5 inches, and that's some unknown number of miles we're trying to find. Okay. So then we can cross multiply. If we do x times 1, that's just x. And then we'll do 582.9 times 0.5. And you had the right idea, I think, in mind. That with 291.45 miles, or however it would tell us to round, maybe on this one. Okay, so the important part on that step, okay, either we got to have miles over miles and inches over inches. You can solve it that way and you'll get the same answer. Or you can do it like mine, where I've got the 2 miles on the top, the 2 inches on the bottom. Okay. Keeping those lined up does 2 things. Okay. It makes the equation work, but also keeps you from having to think too hard. You can just think about, you've got to have the same units either across from each other or on top of each other. Okay. And it'll keep you from getting mixed up. Okay. Because if we had this thing backward, we would have ended up with the wrong answer. We would have had like 1,100 miles, okay, instead of 291. Questions on that one? We just got a couple more of these. We'll start class Monday with those, okay? All right, if you didn't get on the sign-in sheet, make sure you get counted for being here today. It doesn't count for a lot. It just counts mostly in my heart. Okay, so have a good weekend. I'll see you Monday. Right over there.